Hey Chan Physics, just making this quick video on how to do a horizontal projectile problem. Just in case you missed something in class or you're just absent and you want to watch this again. So here is the solution for the first problem. And what it is it's a horizontal projectile. So we've got this cannon that's going to be shooting the ball straight out this way, so straight out horizontally. And then gravity is going to grab it. So as it's coming down, we see it's going to get faster and faster and faster as it's going down, but it's also staying at the same constant velocity going to the right. So the way that we do this problem is we always create this chart with the x and y directions, and then we have all of our variables: vi, the initial velocity, final velocity, distance, acceleration, and time. And what I want you guys to always do is don't try to memorize this. Figure it out from each problem. Make sure you understand where all these are coming from. So what we do is we say, okay, what is the velocity, the initial velocity in the x direction? Well, they told us it's being fired horizontally at 90. And so we might want to draw ourselves this little picture. It looks just as there's our horizontal velocity at 90. There is no x. There's only x component. There is no y. And so our initial velocity is 90. Because our initial velocity is only this way, there's no this way or that way, then the initial velocity in the y direction is 0. As soon as we let go, it's going to start falling, but right now the initial velocity is 0. All right, so what's our final velocity in the x direction? Well, we can see it from our picture, right? As it's going to the right, it's not slowing down, it's not speeding up, it's going the same speed. Therefore, it's 90, just as it started. What's its velocity in the y direction as it's going down? Well, we don't know. Every millisecond or any kind of time at all, it's going to get faster and faster and faster. So we just leave a line saying that's what it is. All right, what's the distance? The distance in the x direction. Well, that's what we're trying to find, really, the range of all of these things. We don't know how far it's going to go. And so that's our unknown. But what's the distance in the y direction? Well, it's up here on the cliff, and it's going to fall this far. And so they told us that the cliff is 4.5 meters tall, so it's negative 4.5. Boom. All right, what's our acceleration? Our acceleration in the x direction is not getting faster or slower, it's staying the same. And so the acceleration is 0. What's our acceleration in the y direction? Well, anything falling on the Earth, negative 9.8. So that's negative 9.8. And then what we saw was in the time, we don't know the time, but we can always know that however long it's going this way, it's also going this way. So the time will be the same for both the x and y direction. That's why we put a little box there to remind ourselves that once we find the time, it's the same for both. All right, so our first column, find the time. Time is defined by the y direction. However fast gravity pulls it down will make a difference as to how long it's going to be flying this way or how long it's been flying this way. So we need to find the time, and so we know that that's defined by the y. And so that means we're going to look at these variables here. Right? We know distance, we know initial velocity, and we know acceleration. And so we're always going to use this equation, d equals vit plus 1/2 at squared. All right, we'll write that equation down, but just know that in all of these horizontal problems, this first term, this vit, is always going to cancel out because our initial velocity for a horizontal projectile is always going to be 0. All right, so we're going to get the distance, negative 4.5 equals 0 times time plus 1/2 times negative 9.8 times t squared. And we have to do some math. So 1/2 of negative 9.8 is negative 4.9. Then what we'll do is we'll divide by negative 4.9 to get rid of that. So we got to do it to the other side as well. And we end up with t squared equals 4.5 divided by negative 4.9, or 4.5 divided by 4.9. And then to take the square root to find the real time. All right. So once we find the time, we'll get we get negative 9.5. We can put it in the box, or we can just know we're going to use that time. Okay. All right. Distance. Distance or range is the next thing. So this third column we'll always use to find the range, and the distance or range is in the x direction. Because it's there's no acceleration. We can use this very simple equation. V equals d divided by t. All right. Which velocity do we use? Well, we don't use 0. We're following the x direction. So we use the x velocity. 90 equals d divided by t. Or 90 equals d divided by 0.95, because we just found that number. If we multiply by 0.95 on both sides, we get the distance, 86.24 meters. That's our range. That's our third column. All right. So in the fourth column, we always find our velocities. So our velocity in the x direction and our velocity in the y direction. The x direction is easy. We actually already found it, right? We found the final velocity in the x direction is 90. We reasoned it out, okay? And then the final velocity in the y direction, well, that's going to keep getting faster and faster the farther it has to fall. So we know it's a little bit more complicated. We use that free fall equation, VF equals VI plus AT, or VF equals 0 plus negative 9.8 times the time that we found. And we get negative 9.31 meters per second. All right, so that's how we do that problem. Now, how do we learn how to do this? Because it sounds like, geez, I just downloaded on you guys, right? And that is what we do is repeat it over and over again. And so what we're just going to ask you to do is start doing this again and again and again for different heights of our cliff. So the next one is going to be, instead of 4.5 meters high, we're going to we're going to do 10 meters high. What will change? Well, in this first section right here, the only thing that's going to change is this negative 10. It'll be negative 10 instead of negative 4.5. But then that's, of course, going to change everything. You'll have negative 10 here instead of 4.5. You'll have a longer time, right? And that longer time will lead to a longer distance and a faster final y velocity. All right. If you repeat this over and over again, and you use the column method that we're talking about, your brain will start realizing, okay, column number 2, find the time. Column number 3, find the range. Column number 4, find the velocities. I promise you, you'll get to the point where you'll like say to yourself, I know the equation that goes in that spot. It is a method of learning that we talked about in class that we can train our brain to look for things in certain places. And this is one of the times that we're going to try to experiment with that and see if you like that, because you can use it more and more in your schooling later on. All right. Good luck to you guys. I'll always be there for you guys. There is a solution set to this on Google Classroom. So if you ever get frustrated or whatever, go look at the solution set. I'll see you later.